Hi, thank you for tuning into this video. In this particular video, I will be explaining the basic concepts of modeling in TAD. I think that is something which a few of you are getting stuck. There are many who have downloaded TAD and have started using it, but a few of them are expecting TAD to work very similar to how CAD and BIM software works. But unfortunately, that's not the case, or should I say, fortunately, because the way TAD models architecture, though it is very different from what you have expected from such programs, it actually is much more simpler, and it results in very small files. And I will be demonstrating that pretty soon, and you'll understand what is going on. So without much further ado, what I would do is that I've started TAD and I've removed the splash screen. When you start TAD, it will show this particular TAD designer light tips. Usually it will show this unless you have set this checkbox off. What I strongly suggest is that you must go through each of these uh, tips here without missing any of them and do it in sequence so that you can get to know step by step how to really understand and model in TAD. You can also translate these tips, just specify the language. Usually the language it will determine and it will give you the hint right here. But in case it is not there, it's a two-letter abbreviation which is used in computers. So HI is Hindi, EN is English, and ES would be Spanish, and DE would be German, FR would be French. You can click on the button here and it will translate this into a particular language which you have selected. So this is using Bing, and that particular tip you can see here. Okay, so if you happen to close it, which I will do now, what you have to do is you can open up the tips again by searching for this particular icon, which is in the help toolbar. TAD also has another user interface, which is you can toggle it to that interface and you can search for tip of the day dialog here. The same icon is here. So usually nowadays I use a ribbon interface, but some people may prefer to use the other menu interface. That's your choice. The interface can be only switched when there are no active TAD models on the screen. So now what I will do is I will quickly open a particular file which I have prepared, which is going to explain the difference between the way we model in CAD and BIM software and the way we model in TAD. So before that, let me just prepare a few things. I'll hide a few of the objects which are not needed. So as you can see in the screen, and I'll just zoom down a little bit by pressing the shift key and dragging a window. And here it is. So on the left hand side is the way we model using regular conventional CAD and BIM software. On the right hand side is how you model using TAD. Luckily for this particular video, TAD does have some capabilities which is pretty similar to what happens in conventional software, conventional CAD and BIM software. So the challenge here in the modeling problem, which I am giving as a demonstration here, is that there is one room with just one door, as you can quite readily see here, and that is getting modeled. Using that, I'll explain how it differs in TAD. So in this particular left hand side, which is the conventional CAD software, what you would normally do in such a case is that you will draw a simple closed polyline, and that polyline will follow the contours of the brick wall which is being constructed, which has to be constructed here. And what I'll now do is that I'll move these two dots. They are called helpers in TAD lingo. And this red square dot is the first helper and the blue circular dot is the second helper. And if you move this around, you will notice that it is indeed a polyline. So it is going step by step to the next edge in continuation. So it is a polyline, a close polyline, and it kind of what we would do if you have to represent a room in a CAD or a BIM software. Now, the point here, which has to be noted, which you have to really digest and understand deeply, is technical drawings, really speaking, came into our lives as architects to explain the construction situation which is there. And some people get confused between this and the whole designing process. In the designing process, there are many different considerations which has to be taken into account. Whereas when you construct something, let's say that this particular room needs to be constructed, and I'll call in a mason. And when that mason comes, I'm not going to sit down and explain what this room is going to be used for and why I designed it like this, why is this doorway on the left, and what can I see from there. I mean, all those design concerns the mason is not interested in. That mason is interested in making sure that the work assigned to him is carried out properly, which is to construct this brick wall over there. And therefore, the drawing actually traces the edges of built matter. And this is very critical in drafting. This is the way we've been taught drafting for years together in architecture schools. That is how you teach the students. So what happens is that your intention is not really to develop a design step by step and reach the point where you have finally realized that you have to make those 4 walls. The problem there is that, of course, architecture is not just built matter, right? Architecture is also about the various spaces this built matter will kind of envelop. So you are, as an architect, you are interested in what is happening inside this particular space, which we can readily see, we can visually interpret it. But mind you, we can see it as a human, we can see it, but the computer internally has got no clue about that particular room. Suppose if I want to take the area of the room, what normally people would do in such a situation is that they will simply click in the corners of this room, and then it will give out the area. In recent CAD software, you probably can click in the interior of the room, and it can kind of figure out what are you wanting. But in cases like this, where the interior kind of escapes through the doorway, probably it may lead to an error. So the only way then is to actually click once again in sequence all those points, and then you will get the area of that room. Now, people do this pretty fast, and when they do it fast, they don't realize that it is because of their activity, that the computer came to know about the area of that room. The computer has absolutely no clue whatsoever. There is nothing inside that particular CAD file which actually defines that room. On the other hand, the computer definitely knows the thickness of the wall, and the computer can be made to get the area of that wall. That it knows pretty well. Now let me switch to TAD. What TAD does is basically, when a project is started, we need to worry a lot about very human issues, right? We live in spaces. We don't live inside the built matter of the walls. We are not termites. So we need to know a huge number of things may capture the attention of the architect who's designing this. For example, he may be interested in the acoustic character of that room, which is based on the volume of the room. That space would definitely play a role in that. They may be interested in the heat which gets developed, the energy which gets consumed in that room, the occupancy of people there, the ventilation, the way those occupants can come and occupy various parts of the room. I mean, there are a million different things, how you would enter from which side of the room. So in this case, it's the bottom left corner. Maybe they may experiment and say maybe it should be on the bottom right corner. All kinds of decisions are made which is to do with spaces. And these decisions, really speaking, and the calculations which come along with these decisions, they need to be done right across the design process, right from the early stage to the final stages of the design where the building is made. And later on, once the building, after the building is made, the same data may be required to be used for checking out what happened in that room, what are the memories which got stored in that room, what type of additional changes you made in the room, whether you put in an AC and therefore you need to calculate the heat requirement, the heat load of that room, and the requirements of the AC, how much tonnage. So this is a continuous thing which happens in buildings. Whereas in CAD and BIM software, the concentration on get that particular job done, which is construct the walls, do everything which is specified, all the material work which is specified, and sure enough, those rooms will emerge from that particular activity. So this part actually confuses people. So how do I do this in TAD? In TAD, instead of talking about the wall, what I do is that I talk about each particular type of space which I'm interested in. So this is the room which is there inside. I can shift this room around. As you can see, it is intersecting with some other shapes, which really doesn't happen in the real world. But that does not mind it, because you may be in the process of designing. It's like doodling, or like bubble diagrams. So now I'll undo that and bring it back. So this type of room space, that is the carpet area of that room, is called an atom, because I've not subdivided it further. This is that doorway which I have placed over there at the bottom left, and that also is actually a separate different volume of space over there. And then I undo that, and this is the outer envelope of that building where I am inside which I am kept this other spaces. So there are three kinds of space. There is this outer envelope, which is, again, I can drag that and place it wherever I want. And I have the inner room, which is it's called an atom. That's a categorization. And this type of space, which is a connector, which connects, is called a connector. It connects between the outside, in this case, between the outside, that is the envelope, and the inside atom. So you have basically three categories of space. That's your job as an architect. You have this, it's like saying you have three alphabets with which you play around, and then you place the spaces according to that, and then you arrange the rooms like something like a Russian doll, set of Russian dolls, one inside the other. Like this particular atom is inside this particular envelope, and then you place the connector. And if you notice, it actually does capture the same wall, which, though it does it in a different way, it does not erase these lines. It doesn't matter actually, because you know there is a doorway here, you know there's an atom here, you know there's a envelope here, you know that a doorway is an opening and it's not built matter. That's the nature of a space, right? So this would get erased. It really doesn't matter. This is not a drafting software. So now what happens is, if I extract the area of the envelope, and from that I subtract this particular room and then this particular doorway, I can get the area of this wall, which is what you get here also. Here you get it because you drew this polyline, and in one shot you get it. Here you have to do a slightly more very tiny little bit more calculation, and it'll tell you the area of this wall here also. So TAD does not compromise on representing the built matter, okay, but it also represents the spaces, because of which you can add a whole lot of properties to it. You can add whatever which comes to your mind, what type of marble you want to use, or flooring you want to use, or what type of skirting you want to use. All that can be specified in TAD. Luckily for us, there is one internal scripting language which I have invented, and that is also available in TAD. That's called Ardala, Architectural Design Language. Using Ardala, I put a script inside this particular file, and now I will run that script for you, and you will see that it actually has recognized this particular classification and the way this modeling has happened. So I'll just click on go, and immediately it has run that particular script, Ardala script, and it's given me the output. So for the left side, the first line is for the left side. That's the way I scripted it. So for the left side, it has got only this particular closed polyline. So because of that, it can only calculate the area of that wall, which is 2.5576. That's all what we know from that, right? But if you go to the right hand side, because it knows the envelope and the atom and the connector, it ends up with all these capabilities of analysis. Like you can find out the carpet area of the room, you can find out the built-up area. Built-up area is the entire envelope area. You can get the door opening area, which is just this area. You can get even the calculated wall area, which obviously is the same as the wall area which was calculated in the previous example of the CAD file. So this is how TAD works. It works by allowing you to express quite symbolically, linguistically correct ways of talking about all the various elements that piece of architecture contains. Now, in this particular case, I have just created one room to explain what are atoms and envelopes and connectors. But if you were to go into this, you'll find that you can use atoms, envelopes, and connectors right across for all kinds of projects, all kinds of buildings, and there is no end to how you can express it. Now, some of you may think, this is a lot more complex, right? I have to do 3 different things here. Whereas here I just did one thing and I got the job done. And I can see for myself visually, I can see that there is a room there. Yeah, I do agree that that may sound simple, but you have to understand the reason. One of the reasons for TAD is to deposit responsible information about your design and the entirety of the design. In this case, you're giving only information about the built wall. You have not really given information about that room inside. That information is coming because you happen to examine it and then you happen to click on those internal corners of this polyline to get the area, for example. Really speaking, that data is not available inside that particular file. So what happens is that you are, as an architect, you are given partial information for future usage. Whereas TAD, you are putting all the information. So even after years later, when the whole building is ready and you want to then develop further on the kind of activities and facilities which needs to be managed in these rooms, you can still use the same data. You don't have to do any additional work. Not just that, as you work, because each of these spaces have got logical names, which is listed here on the left hand side, it actually immediately tells you, does not wait for you to click anywhere. It knows that this is a simple room, that area is there. What is the area of the doorway? Click there, tell you the area is this. And the same is available through Ardala. So the Ardala is not asked you to interact. Ardala is a non-interactive computer language. So it does not interact with you. It just goes about picking up all the logical spaces which you have represented and then works on it. Let me give you another example of a Bombay municipality FSI calculation, that is municipal calculation, the local regulations calculations which need to be done. Sometimes these calculations can be extremely convoluted and intricate and you can very easily make mistakes. So here is the entire building. In that case, earlier case, I was just showing you only the one room. And this is actually a 3D system. So you can actually see this building, the basic massing, and actually the internal details are also there. This is just a preview, so it does not cut out openings and all that. This is just to get an idea about how the building is shaping up. Now this model is ready or ready enough for you to start doing calculation. And all you have to do is to run another Ardala script for Bombay Municipality Corporation FSI calculation and just click on go, and it will immediately give you all the required details of how many doors, windows, what is the permissible balcony area, how much FSI you've consumed, and all the kind of things which you would need in that particular project. So TAD can handle things which are very simple for you. Now, in this case, this was a very simple room, right? But it can be very complex also. And the joy about using TAD is that probably for very simple things, it may sound a little crude and clunky. But as you start fleshing out various things, you start thinking about, oh, you know what, can I get a sight line from here? And can I look out to this part of the world outside from inside the room? All those kind of things you can do. And there is a lot of things which it gives you for doing that. Like there is a concept of an architect who's kind of saying that I am standing here, kind of, a position pointer kind of thing. So if I am standing here and if I want to know what is the length here or to the length to this point, it gives you that. It is called the architect's distance. So this distance is at this stage it is 2.4348. So things like that. So you can shift the helpers to another object and then get that distance. Immediately the distance is available here on the left hand side, and you can get that distance. So that's 5 meters to this first helper, which is the red square. So there you have it. That is what really modeling in TAD does. As I told you right in the beginning, you need to really go through these tips here. And there is another thing which you can do, which a lot of youngsters do. They don't like to read any books or anything. They just want to play around and hope that they'll get to understand the software. You can do that here also. You can just click somewhere here and then press this heart symbol here, or kind of hand symbol, and it will tell you the context sensitive help of the last action which you carried out. So you can just merely click away and say, okay, what did I do just here? What was this about? And it will tell you what it is about. You start reading that, and that is how, that is also one way to read this. Without reading, you really cannot learn anything for that matter, rather than something very superficial. So this is just an introduction to TAD. There are many different things which TAD does. TAD is not a drafting software. Don't look at it like a drafting software, but it has got aids for drafting. You can export section lines. You can export dimensions. You can export the model itself. You can export parts of the model and then work on your CAD files. That is how my office does. I do the designing in TAD, and once I've done it in TAD, I never really have handled any CAD software directly. I don't need to, because I know that the design is fully explained here, and my junior architects and others in my office, they can simply export it and start drafting with that. So that's how TAD works. I hope you will enjoy using TAD. TAD is a free software. It is one of the oldest design software. It walked along a different path than others. That's the way things grow when you don't have any reference point. So the user interface is different. The way you model, as I showed you, is different. But you don't have to get worried. It is just a matter of getting used to this, and you will start really enjoying. You'll find that if you try to model everything using this method of, delineating each built matter over there, it's going to make it very heavy and take a long time. It may not be convincing here, because here you saw me drawing 3 different objects, but here there is only one object. But if you were to really work out the maths and click on each of the corner, you'll see that the number of corners here grow up quite large, whereas here the number of corners is actually quite less. And you can see this also in the size of files. If you see the files of TAD files, they're very, very tiny. They're literally in kilobytes. And one of the reasons is because the way the modeling is constructed is that it is complete. It talks about space as well as built matter, and at the same time it does it very efficiently. So you actually spend very little time doing all the drudgery. There's not much drudgery in TAD. Half the time you're really thinking as if you're fleshing out a design through bubble diagrams and then making the design grow to your expectations. And then you can work out multiple alternatives, which is also one of the goals for TAD. So please visit teamtad.com and like I said again, I'm repeating, it is a free software. It requires a registration where you have to register yourself at Discord, and I suggest you give yourself an anonymous name so that you know that you can do designs without really getting affected by people's personalities. And that is required, and then you can start using TAD. If you have any problems, you can connect with the community on that Discord community and ask your questions, and we will help you there. And I hope you can spread the news about TAD. It is a pretty interesting software. There are many other things which I can tell, but for lack of time, it will end up becoming a pretty long lecture. You can, for example, you can export the data of TAD in many different computer languages. All kinds of different things are there, which is not seen at all in any any other program like CAD software or BIM software. So it's extremely easy to extend TAD and work on it, develop programs in Ardala, and really do a good job of designing. So thank you so much. Have a nice day. Thank you.